Stay safe, happy learning. My name is Amarnath and I am a certified energy auditor from Bureau of Energy Efficiency, Government of India. Starting from coal classification, in this video we shall learn analysis of coal engineering chemistry. Coal is classified into three major types, namely anthracic, anthracite, bituminous, and lignite. However, there is no clear demarcation between them, and coal is also further classified as semi-anthracite, semi-bituminous, and subbituminous. Anthracite is the oldest coal from geological perspective. It is a hard coal composed mainly of carbon with little volatile content and practically no moisture. Lignite is the youngest coal from geological perspective. It is a soft coal composed mainly of volatile matters and moisture content with low fixed carbon. They may have moisture content as high as 50%. Fixed carbon refers to carbon in its free state, not combined with other elements. Volatile matter refers to those combustible constituents of coal that vaporize when coal is heated. The common coal used in Indian industry are bituminous and subbituminous coal. The gradation of Indian coal based on its calorific value is as follows. Grade A coal that exceeds 6200, that is 6200 kilocalorie per kg. Grade B 5600 to 6200 kilocalorie per kg. Grade C 4940 to 5600 kilocalorie per kg. Grade D 4200 to 4940 kilocalorie per kg. Grade E 3360 to 4200 kilocalorie per kg. Grade F 2400 to 3360 kilocalorie per kg, and grade G 1300 to 2400 kilocalorie per kg. Normally D, E and F coal grades are available to Indian industry. The chemical composition of coal has a strong influence on its combustibility. The properties of coal are broadly classified as physical properties and chemical properties. Let us discuss physical properties. Heating value. The heating value of coal varies from coal field to coal field. The typical gross calorific values for various coals are given here in table 1. This table parameters: gross calorific value. Lignite dry base is 4500. Indian coal 4000, Indonesian coal 5500, and South African coal 6000 kilocalorie per kg. Now, if analyzing the coal, there are two methods to analyze the coal. They are ultimate analysis method and proximate analysis method. It is pertinent to note that this proximate has nothing to do with approximate. The ultimate analysis determines all coal component elements, solid or gaseous, and the proximate analysis determines only the fixed carbon, volatile matter, moisture, and ash percentage. The ultimate analysis is determined in a properly equipped laboratory by a skilled chemist, while proximate analysis can be determined with a simple apparatus. It may be noted that proximate has no connection with the word approximate. Measurement of moisture content of the coal. Determination of moisture is carried out by placing a sample of powdered raw coal of size 200 to 200 micron size in an uncovered crucible, and this crucible is placed in the oven kept at 100 plus minus 2. That means 105 to 110 degrees C along with the lid. Then the sample is cooled to room temperature and weighed again. The loss in weight represents moisture. The boiling point of water is 100. So at 105 degrees centigrade, after being heated for an hour and so, no water content will remain there. So the sample is free from moisture. So the loss in weight represents the moisture. Measurement of volatile matter. Fresh sample of crushed coal is weighed, placed in a covered crucible and heated in a furnace at the temperature of 900 plus minus 15 degrees centigrade. For the methodologies, including that for carbon and ash, IS 1350 can be referred. The sample is cooled and weighed. Loss of weight represents moisture and volatile matter. The remainder is coke, fixed carbon, and ash. All volatile matters and moisture is removed at this temperature, and the remaining sample is coke, that is fixed carbon, and ash. Measurement of carbon and ash. The cover from crucible used in the last test is removed and the crucible is heated over the Bunsen burner until the carbon is burned. The residue is weighed, which is the incombustible ash. The difference in weight from previous weighing is the fixed carbon. In actual practice, fixed carbon or Fc derived by subtracting from 100 the value of moisture, volatile matter and ash. Now, what is proximate analysis? Proximate analysis indicates the percentage by weight of the fixed carbon, volatile ash and moisture content in the coal. The amount of fixed carbon and volatile combustible matter directly contribute to the heating value of coal. Fixed carbon acts as a main heat generator during burning. High volatile matter content indicates easy ignition of fuel. I repeat, fixed carbon acts as a main heat generator during burning. High volatile matter content indicates easy ignition of fuel. The ash content is important in the design of the furnace grade, combustible volume, pollution control equipment and ash handling system of the furnace. The typical proximate analysis of various coal is given in table below. Parameters chosen are moisture, ash, volatile matter and fixed carbon. These are the 4 parameters of proximate analysis. So for Indian coal, moisture 5.98, for Indonesian coal 9.53% and South African coal 8.5%. Ash, Indian coal 38.63%, very high ash content, and ash handling of Indian coals is a big problem in challenging task in thermal power generating plants and other boilers. Indonesian coal 13.99% and South African coal 17%. Volatile matter 20.70%. Indonesian coal 29.79% and South African coal 23.28%. As said earlier, the fixed carbon acts as a main heat generator during burning, and high volatile matter content indicates easy ignition of fuel. So Indonesian coal and South African coal has higher volatile matter. So with naturally it is easier to ignite Indonesian coal and South African coal than Indian coal. Fixed carbon, Indian coal 34.69%, Indonesian coal 46.79%, and South African coal 51.22%. That's all in this video. Thank you. Stay safe. Please check your subscription so that you don't miss next video from this channel. Thank you very much.